What did you study last year in physics? Valentino?
Light.
Light, good.
Didn't we do the mirror?
Mirrors? Yep.
Waves.
Waves.
And then how the eyes work and like the eye stuff.
Yeah, you remember the eye stuff.
And the ear stuff.
And the ear stuff, yeah.
And the moose eye.
Yeah, great.
That
This
was
is
nice.
physics, not biology. Yes, so we did waves. And we did the detectors that we have got of two big types of wave. Light waves without eye and sound waves without ear. Okay? And actually, the grade 7 physics is quite easy, and there's a lot of experiments that you can do. So now the catch is the grade 8 is actually quite difficult. Yay. It's difficult, but it hopefully will make you curious. And I know how some of you like asking questions. And I'm going to try to get you to answer the questions. It also, I'm afraid, gets to be mathematical. I can hear you cheering. Some of you are quite good at maths. Some of you are, don't want to do that. So it gets to be a little bit more, it gets harder. It gets harder. It gets harder to work out the answers and get concrete answers to problems. You know, like saying, yeah, this is a fact. Here's the numbers to prove it. And it also can get conceptually more difficult. We are going to start dealing with really, really obvious stuff. But then we're going to need to think about why it is obvious. And is it really obvious? And I'm boring you already. So it's okay to ask questions. I get upset if you don't ask questions. Yeah, so you did light, you did sound, you're tired as well. I saw that yawn. You tried to hide that yawn.
Karen, yawns are not only for tiredness.
Yes.
They can also express boredom, or if you're hot, it cools your body down.
Yeah, and so hot I need to cool my
Keep
body.
going.
It brings oxygen to the brain.
Yeah, I need to work better, so I'm yawning.
Purposes.
And it can be contagious, so you can yawn.
Yeah, it's contagious. It's amazing, isn't it? Yawning is contagious. Why should it be contagious? Why should a behaviour that gives you more oxygen to your brain be contagious? Yeah?
Maybe if like there's many people in some situation and someone thinks of something, then they all do it so that like if you need more oxygen to your brain or if you need to cool down or stuff, then you need to yawn and then you yawn and then everybody else starts to yawn and then it's an endless cycle. And then you're like,
I wonder if it is a bit like that, a visual trigger, like, hey, we're going to do something, let's get more oxygen in our brains. It's also contagious with animals. Yeah, oxygen in your brain, Alpha, to do hard work. Science. Yeah.
Yeah.
Now, at the end of last year, oh, I erased it. I'm also very lazy as a teacher because I've got all the answers in the lesson I taught before, only I erased it. Okay.
And she doesn't give good grades.
Why did you say that?
Because you told us that you don't give us good grades.
Did I give you a good grade?
Well, yeah.
So
she maybe doesn't give good grades.
perhaps I lie.
Oh.
What if, as teachers, we were allowed to tell you one lie a day?
Oh yeah, you
Yeah.
told us it. Yeah, you told us
Mm.
many times.
No, I haven't.
Okay, maybe just once then.
You did there.
Well, there's this big thing at the moment, isn't there, on social media about news that is false, fake news, and how breakouts of fake news seriously influence things. Did it influence the US election, perhaps? Do you instantly believe everything that you read online and then you click and share it? Because some of it is really, really bad lies. And some of it's just plain funny, so it needs to be shared, but then some people might believe it. Yeah, okay, all right, I will try not to lie to you. I'll try, or is that a lie? Okay. Last year, you studied bits of the electromagnetic spectrum. Do you remember that? Some of you look like you've never seen it before. Visible light, here, and then infrared, ultraviolet, microwaves, radio waves, X-rays, and gamma rays. And they are all waves. So they all have a property where something oscillates up and down. It goes up and down. And actually, we can't see these. We can't see light. We can see because of light, because our eyes have developed that detector of light, but we can't see light. I can't see the light rays travelling from the lamp to the board. I can see the screen because of the light that's on it. I can see you because of the light that's on you, but I can't see the light. You can hear the words I'm saying because your brain is translating them, but you're actually not seeing the sound waves, the vibrations through there. You can't see an X-ray. You can see an X-ray photograph. So we commonly say, here's an X-ray of your broken leg, or something like that. But we cannot see the X-rays. So a lot of things we deal with in physics are invisible. They are obvious concepts. Oh yeah, we can see because things are light. It's an obvious thing to say, but it's actually quite hard to understand. And the topic we're going to look at this term, I think, is one of the worst to understand. And I get confused about it. It's hard to explain a lot of the things that I get asked. I get asked all sorts of random stuff. It's easy to explain in grade 7. It's fairly easy to explain in grade 9, but grade 8 is difficult because we are going to be dealing with forces. In Finnish? Voima. Yeah, forces. I'm going to be thinking about what is a force. Where do we get them? What causes them? Why are they so important? Gunnar, you don't look happy. You don't look happy. No, you're not happy.
He's very happy.
Why not? Forces, you don't like the sound of it.
And we started school yesterday,
So, you've had a day to get used to it.
which ended at 4 o'clock.
He started at 8.
Yeah, okay, yeah, that's bad. Yeah, you come here in the dark, you go home in the dark. Yeah,
Dark.
you little mushrooms. You're grown in the dark. Actually, there's a very, very rude joke I know about that. Well, it's not really a joke, it's a phrase. Well, as a staff, way back in the school in England, we used to describe ourselves mushrooms because we were kept in the dark and fed bullshit by our bosses. So, yeah. Little mushrooms, you are not fed bullshit. You are fed knowledge to nurture you and make you grow.
Or are we?
Yeah.
Yeah, you are actually. Yeah.
Okay.
Or maybe. So yeah, this is difficult. It's difficult to get your head around what are forces, why do they happen, etc., etc. Actually, when it comes to tests, you just get tested on the simpler stuff. I'm not going to make you go into all the detailed philosophy of forces. But it's kind of sad, actually, because one of the most famous examples of force is...
Star Wars.
Exactly. And Star Wars, May the Force be with you, has absolutely nothing to do with what we're going to do
Isn't
this
it like,
term.
isn't it the force that this wants to go down? And then if you have the force, then you can control it.
Oh my God, please don't.
What do you mean, please don't? What do you mean? Okay. Search long enough on the internet and you'll find some nerd who's tried to relate Star Wars
The force is a binding metaphysical.
to physics force.
Oh.
This was my Sunday.
The force is a binding metaphysical power that unites all living things in the universe. Of course, that's just in Star Wars. There's nothing like that in the real world that people could use to levitate objects or influence people's decisions. Or is there? I'm Rusty Ward, and I'm kind of obsessed with figuring out how I can attain real superpowers. Powers like the ones we see in sci-fi films and read about in comic books. In past episodes, I've explained how to get an Iron Man exoskeleton and heal like Wolverine. In this episode, I want to find a real-world equivalent of the Force. Darth Vader and Obi-Wan Kenobi talk about the Force as something that's all around us, that's ever present. They can sense changes to it, use it as a form of telekinesis, or to manipulate someone's mind. If we're looking for a real-world equivalent of the Force in our own universe, we should start by looking at the four fundamental forces. These are gravity, electromagnetism, the strong force, and the weak force. Gravity is the force that attracts physical bodies to one another. The strong force is what binds protons and neutrons inside the nucleus of an atom. The weak force deals with radioactivity and subatomic particles. Electromagnetism is the interaction between electrically charged particles and magnetic fields. If I were looking for a force in our universe that most resembled the force in the Star Wars universe, it would be electromagnetism. It's stronger than gravity and has a longer range than either the strong force or the weak force. We're surrounded by electromagnetism, and it affects all matter with an electrical charge, which is all life. But even if electromagnetism is all around us, can we use it to sense our surroundings? Can we sense a great disturbance in the force like Obi-Wan can? Or sense the force in another person the way Darth Vader does? Well, sharks can. They have an organ called the ampullae of Lorenzini. This organ allows them to detect the electromagnetic fields of the objects around them. They can sense great disturbances like a ship with a large magnetic field moving through the water, or small ones, like a fish that's about to become lunch. But anyone that's ever read a comic book featuring Magneto knows that magnetic manipulation only works on metal objects. We couldn't use electromagnetic fields to throttle the windpipe of an insolent subordinate the way Darth Vader does, right? Wrong. All objects can be influenced by magnetic fields. Metal objects are just more susceptible to them. If something like a human being is less susceptible to magnetic fields, that simply means we need a stronger magnetic field in order to manipulate it. If you have a strong enough field, you can levitate a living organism, like the frog in this video that's being held in midair by a high field magnet. Electromagnetic fields can also affect people mentally. If you direct magnetic fields at different areas of the brain, you get all sorts of responses. They can be used to completely pacify a subject so that nothing at all bothers them, such as two suspicious droids passing through a stormtrooper checkpoint. They can be used to make someone hallucinate, like hearing a bunch of rebels on the other side of the hangar. And they can even be used to alter someone's sense of morality, so it may seem okay to go over to the dark side. So the Force is with us. We just have to learn how to manipulate it. For that, check out the future episode of Science Friction that takes on Magneto. Thanks for watching. Be sure to subscribe and check out some of the other episodes of Science Friction that tell you how to fly.
So, what do you think?
I think you use Internet Explorer.
What?
I think
Why should I use Internet Explorer? Why is it better?
No, you should not.
Why?
Because it's slow. And it's bad.
So, some of the things that are hinted at in Star Wars, or not hinted at, but the action at a distance, being able to throttle people from a long way away. Well, there are indications that forces can do things like that. We just maybe haven't developed the technology yet. I mean, think about the age we're living in. When I was a kid, there was no internet. Even had a, I know it isn't that long ago, less than 100 years ago. So when you were younger, you didn't have iPhones. iPhones have been out for how many years? 10. Yeah. So you won't remember the world before iPhones, or smartphones, but they weren't there. So technology is changing a huge amount, and that's all really, really advanced stuff. That's the nerd trying to be clever and say, someone's had this amazing science fiction idea, could it ever really be true? And he was talking about you don't have to write this bit down, the 4 fundamental forces of nature, which physicists, scientists love. They have been able to explain the interaction of the world in terms of 4 different forces. Basically, everything to do with light, heat, that electromagnetic spectrum, and electricity is to do with the electromagnetic force. Everything to do with radioactivity is the weak interaction, very, very, very tiny, and a bit of the strong interaction, what's inside the protons and neutrons, inside the nucleus. So atoms, nucleus, yeah? But when you get to electric charges, like the electrons whizzing around, that's electromagnetism. And these have all been put together in great complicated calculations that only super, super, super nerds understand. Okay? And then there's gravitation, which is actually the easiest to get to grips with force, and the one that we all learn about from a very, very early age. Because you do it by instinct. How many of you drove your parents mad? Or doing that again and again and again with your favourite toy? Yeah, cats are still doing it all the time. Okay, you learn to walk. You learn to balance. You're into sports, I would guess. And sports rely on loads and loads of stuff around balance. Don't we know it just at the moment, as this wonderful temperature is going above 0, will go below 0, and everything will be ice. And non-fins like me are just going to fall over a lot. Hate it. Low friction endurance. Yeah, lots of people hate it. But also, it's responsible for skiing and skating and stuff like that. And anything you're doing where you're throwing or lifting, then you're working with gravitation. Cheerleaders, any of you? Okay, I thought you weren't injured enough. Are you? I have an immense amount of respect for cheerleaders after the last few years of teaching people on a Monday morning with massive great bruises and bandages. I've decided it is one of the most interesting sports physics-wise, because it's gymnastics and huge amounts of strength. And there's a ballet person in the other group, and that's made me think as well about the physics of that. So what hidden sports have we got here? Football. Football's a fairly easy one, sports-wise. You do ballet as well. Good. You can ask me about ballet stuff and tell me about ballet stuff. Because actually I learned something yesterday. I learned about how you stop slipping over if you're on the point. You soak your shoes with water. Yeah. Didn't know that. That's really interesting. Good. Vinia.
Synchronized swimming.
Oh yeah, synchronized swimming. Yeah, okay. How forceful is that? What forces are involved in that?
I don't know.
Aha, well maybe we'll find out. Synchronized swimming. I don't think I've ever taught a synchronized swimmer before. Okay, yeah.
I do competitive aerobics.
Competitive.
Aerobics.
How do you do competitive aerobics? What do you do?
It's like cheerleading, dancing, and gymnastics together.
OMG, really?
Yeah.
Ouch. The potential for damage in that is huge. Baseball. Nothing wrong with that. Actually, baseball, the physics of it is really, really quite difficult. The physics of football is quite difficult as well. So it's mainly the girls who are sporty, is it? Mainly, I said, oh.
I cycle in the spring.
The spring and the summer.
Yeah, like-
What's wrong with?
If there's ice and it's cold and I don't want to cycle 30 kilometers in the snow.
That's not a sporty hobby, though. You live 30 kilometers away.
No.
No, for fun, in my free time, I cycle.
Free time.
Yeah.
Okay.
Like a hobby, but.
Okay. So we are generally going to focus on the mechanical forces, gravitation, with a little bit of electromagnetism in there. But that, when you hear about the 4 fundamental forces of nature, that's what physicists are talking about. And that's really, really difficult. So we leave that behind and we go back to the absolute basics, some of which are going to be wrong, but they're going to help. Yeah.
How do the magnetic get how the magnetic things form or come?
Magic magnetic little elves inside the magnet. How does any of this happen? Some of it we have to accept it just is. But magnets work because of the way the electrons are organized. You can't get away from electrons. Okay. Well, I'll try to explain stuff like that a bit later on. But it does get to the level where I have to say, well, this is just fundamental. I can't explain it anymore. It just is. You have to accept there's this thing called electric charge that causes electromagnetism, the electromagnetic spectrum. It causes friction, it causes magnetism. You just have to accept that exists. A bit like accepting God exists if you believe God exists, but you can get into all sorts of debates about that as well. What? Why? It's healthy to debate. You don't want to talk about God. Okay, we'll leave.
It's not healthy to debate with like guns, and a lot of people do that when it comes to religion.
Yeah.
Have like scientists do they have information about those things that you said that just exist? So do they have knowledge about that?
No.
That's why you said about Internet Explorer, because this has just opened up an Internet Explorer. Sorry, non-linear pattern.
It just says play.
I know, but Valentina doesn't like Internet Explorer. Scientists will always question. That's kind of part of the job description. If you've got something that they say, scientists say is fundamental, you can't get any more basic than that. You just have to accept it, that is how it is. And I think what physicists are trying to do, scientists in general are trying to do, is to get down to the very, very basics. So, for instance, when we were studying chemistry, it was a case of, why do we have these reactions? Oh, it just is. That would be the answer for many, many years. And then people say, okay, well, why should it just be like that? So then the theory of electronic structure in atoms came about. Now, actually, scientists aren't happy with this form. People say, is there a fifth? Could there be a fifth? Is there any evidence of a fifth force? Other people are saying, are they all part of one? And in fact, equations have been made that have linked those together, but gravity's on its own. So then the question is, why is gravity on its own? And it's almost like it is not satisfying to physicists to not have an answer. There's always a discussion about GUTS, G-U-T-S, the grand unified theory, the equation that will sum up everything. And that then is also where you get the other extreme of saying, why can't you just accept? Why can't you just enjoy rather than try and find an answer? It makes human life very interesting. Back to the very, very basics. Back to a really irritating movie for kids.
With
With a
many,
lot of ads.
I know. I don't get those ads at
It's
home.
11 minutes and there's like 10 ads.
I know. Sorry.
Money.
You guys know anything about force? Let me tell you, okay? Nothing in the world moves without force. A rock won't just fly through the air out of force. It takes a push or a pull to move it. That's force. And I bet you can do it. Like, you see the soccer ball, you think it will move? Not until you apply some force, my dude. So run up. Oh, that's motion, no trick. And if you gave it less force and kicked it softly, it wouldn't have gone as far. You got me? And if the ball weighed 50 pounds, it would have been really hard to kick around. It takes less force to move things that are light. That's why it's so easy to pick up a mic. And it's way harder to pick up a brick. That's it. Now let me drop the hook real quick.
You need force to make an object move. It won't move without force, that's true.
It won't move without force, that's true. A push or a pull will move it around, but friction will slow it down. You need force to make an object move. It won't move without force, that's true. A push or a pull will move it around, but friction will slow it down. So you know it takes force to make something move. It also takes force to make it stop, that's true. So when you kick a ball to your friend Lou, and he kicks it back, he applied force too. But then why does the ball stop on its own? When you kick it, why doesn't it keep going? It slows down because of friction. Friction is a force of resistance. When the ball rolls and touches the grass, then those two surfaces interact, and friction from the grass on the ground is what slows the ball down. But what if it were ice instead of grass? Would the ball roll less or roll more, you ask? Ice is smoother, so there's less friction, kid. That's less force on the ball. Are you getting it? The ball is gonna go farther. Like surfers when they surf on water. Water and ice are slippery and smooth. They have less friction, so it's easy to move.
You need force to make an object move. It won't move without force, that's true. A push or a pull will move it around, but friction will slow it down. You need force to make an object move.
It won't move without force, that's true. A push or a pull will move it around, but friction will slow it down.
It's then repeated for 11 minutes, by which time you will be begging for the ad break. Oh, come on. Okay, you have a 3-minute stretch break, movement break. Go get some fresh air and get rid of that earworm.
It's not possible.
Everybody has one.
Get out.
Oh, yes.
Get out.
Oh, yes. That's the theme of this term. You will remember your unit. Okay, I usually, because this is a 90-minute lesson, you normally get a stretch break to go and move and check your phone.
I left it in the class in front of me. Well, no, there's only one person checking their phone. That is impressive. Volunteer, you've taken your bag, you said 2. You are? I think I did say stuff. Physics is the hardest movie to follow. I need to go and write that down.
And can I remind you when you're finished gossiping that there is now somebody here who doesn't understand properly. So, English. Right, 3 minutes is now up. That's a teacher 3 minutes.
Have you seen me do in the talent show sometimes? If you see me perform in the talent show, that's my hobby.
Yeah, okay. But I must admit, I've not heard of it. Yeah. But it actually strikes me as a really difficult thing to do. Yeah. But then again, any sport, if you've got a hobby that's become a sport and you're doing it into grade 8, you're at a pretty high standard of doing it. Baseball or synchronized swimming or whatever. Because actually, synchronized swimming, I can imagine, I'm not sure it's a sport, I must admit.
It's a sport.
Okay. But I can imagine it's really, really.
What do you think it's like? Describe, what do you think it's like?
You can draw if you want.
Okay, are we gonna?
No, but I'm
No,
telling you what
okay,
it is.
I will tell you, yeah. Thinking about the Olympics and sport there, and to me, it's a bunch of really heavily make-upped people wanting to look like mermaids. It's dancing in water. And I hate the way it looks. Because it's majorly glamorous. But if I think about it, I worked with a guy who was heavily into ballroom dancing once, many years ago. And then he actually started looking at the moves that are made, like any dancing. And it's really, really, really difficult. Now, I admit I've never thought about synchronized swimming. And I admit, if someone like you's doing it, maybe I ought to start thinking about it seriously.
Like most people think it's just, we just float in the water.
No, you don't.
No, we don't.
I've seen you do the upside down flamingo thing where your feet are like this and then you're like upside down head in the water and then you're like it looks really difficult and I once tried it and I was gonna like
Yeah. The more I think about it, the more difficult I think it's got to be, and I would actually have to look at the moves, the choreography, and start thinking about forces in it, as I would with ballet.
It's like usually when we do things with legs, it's like we are upside down in the water like this, we only use our hands. Instead.
Yeah. Yeah. And now, as someone who really has difficulty staying upright because my ear doesn't work, I think I've got a huge amount of respect for those balance sports. Yeah, because you are with synchronized swimming. You know, it's. I've never thought about it before, and it's actually really obvious. You are balancing in a way that we ordinarily balance because you haven't got the ground and you haven't got the air. You are just in water, and that must make it really, really difficult.
It's like rolling in the water every day.
Yeah, it must do.
Turning upside down.
Okay, now, when it's marked in the Olympics, it's marked on how the whole team does. And that,
I think it's so that you usually can fly, you can compete with like vertical or solo. It's because there's one person that will like the sport sports like based on teamwork.
yeah. Now, okay, teamwork's important, but
That's why I think nowadays you can participate in like a combo or something.
yeah. I think if synchronized swimming's in the Olympics, then cheerleading
It
ought
is
to be.
there.
Yeah, but cheerleading then ought to be there, because cheerleading is much more than just waving a few pom-poms around. And in fact, then why shouldn't ballet be there? But it is in some ways, I suppose, with gymnastics. What is the a floor routine? When you look at floor routines, how very different are they from ballet? Well, ballet is to do, to my mind, with lots more smoothness and less lifting your own body. But then again, you know, if you're going to be a ballet dancer, you've got to have amazing muscle control and balance and all the rest of it. How good is your balance, Ash? Right, if we'll leave Cole. You know, have you ever done the balance test where you have to stand with your eyes closed and stand on one leg? Okay, when you're young, you're meant to be able to do this for quite a long time. When you're my age, you should be able to do it for 6 seconds or so. So, if I fall, I'm going to fall on a table, that's okay. So, let's see. What was that?
5.
No way. More like 2 or 3. What can you lot do? I'm intrigued with all the pressure. Okay. Don't touch. Shut your eyes, stand on my leg, ready now. Open your eyes when your foot's down. Open your eyes when your foot's down and see who's still going.
Oh, wow.
Wow.
Only.
Wow.
Last one.
No.
Oh, you should be telling me.
Wow. Brilliant.
You're supposed to.
Was that difficult? Was that more difficult than you thought, or easier?
I don't know.
Yeah, and it also depends which leg you stand on. Okay, sit yourselves down. It is a standard kind of how good your brain is at adapting to balance, etc., etc. And I suppose I was thinking you were going to be really, really good at it, and you were going to be really good at it, judging from the training that you've had. The rest of you I wouldn't know about. It's yeah, interesting. Okay, let's get so synchronized for me. Yeah, I've always gone on what it looked like.
Let's see.
I have not gone on what I have not thought ever until now about what it involves, and I think I've got a much bigger respect for it.
Usually people have the image that it's like just people falling.
No, it's not. No, I knew it. Yeah, it wouldn't
I
be.
think next time is the Olympics. You should, I think it's the Summer Olympics. I think Summer Olympics.
Yeah.
You should try to watch it as the Russians do it.
Why the Russians?
They do like it massive.
Sorry,
Russian.
Russians.
I mean, it's very inhuman to watch. Karen, what's the super how? Like exact time. It's all the I can raise it like a hell on the water. Elena, I can raise that and fight. They look like sure.
Okay, how do you do that maneuver?
That's how.
that. Not that. Yeah.
I don't have to lower or high.
How do you? No, I'm now thinking. Right, you want to stand on your. You want to stand on your hands. What do you do? What do you do if you were in the air? What would you do? How?
Like usually
Now hang on a minute. The rest of you think about this. You want to do a handstand? Yeah.
Then you put your hands on the ground, but you
Right.
can't do it there.
Hands on the ground. You can't do it there.
But you do like,
No, you don't,
No.
because that water is still. How do you do it?
usually it's like usually I think they go like underwater, they go like this, and then they like when they body, it's like they put their stomach next to the legs like this.
Yeah.
It's like they put their hands on their knees and then they do like this. Or it's like the bottom is here. Just think move like this.
Because they're all at the same height. The
Yes.
tops of the legs are all
They're
at
all
the
at
same
the same
height.
height. They go all at the same rhythm.
Same time. They use different forces, different sizes of forces. Yeah. Okay. All right. I maybe better not. Can I criticise the makeup and the that
No,
though?
it's just a look.
The look, yeah, like ice skating. You don't have anything hard to push against, but that's really, really difficult.
It's kind of like funny. There's like, and I think Mia also does it like not the mikä se missä tehdään näin se ilman käsiä sille että sen hyppäät sivuuttaa niin.
Yeah, so your core strength must be absolutely. How long can you plank for?
I didn't count.
Okay.
Like 3 hours.
Yeah, it will be.
What?
Goodness. Okay. Right, let's get back to some basic. You wrote that as a title, didn't you?
No.
Yeah? No? Okay, write it as a title, or write force. Okay, I'm learning a lot this week. Newfound respect for ballet, newfound respect for synchronized swimming. One more question. Is it different according to which swimming pool you're in?
Swimming pool?
Like,
Do you always use the same pool to train in?
Yeah, but it's really hard because like I think all have this swimming pool like according in all around. Every time we go to somewhere, the place we usually do the competition in is too like it's not deep enough or it's usually not deep enough and it's hard to do other moves because if we touch the bottom, it's like we might get out. It's like didn't count up.
Yeah. But, okay, right.
And usually the design of the pool is just not.
Yeah. Okay. Right, so force was voima in Finnish, which is not teho. Because teho is power. And we do have a problem with language. Our everyday language can be different. It's not energia. Force and energy are not the same thing. And also, it's not työ, work. Okay? These have very specific meanings in physics.
how could it be työ?
Work.
Yeah, but like how would force mean työ?
if you thought force, then you probably wouldn't think työ.
No. But there is a physics term called työ, also, which directly translates as work. Like in a workout. And I'll explain that more towards the end. Yeah. Okay, so then what is a force? That's where the earworm comes in, which I'll try to change. A force is an interaction. Do you all know what I mean by an interaction? What is it in Finnish?
It's at the tip of my tongue.
Yeah, I can hear that.
No, really, I have a.
It's like when.
Yeah.
Yeah, vuorovaikutus. Okay. A force is an interaction which, bless you, tries to move or change an object's motion. That's a more correct interpretation of it. Put very simply, it's a push or a pull.
There is no try.
No.
There is a lot of trying. At the moment, gravity is trying its best to pull you down, but it's not winning.
It has to push or pull.
It often does win with me.
It often does win, yeah. Me too. Okay, so some forces have specific names. Not all of them, because there are billions and billions and billions of them. So, gravity. Fine, oh boy. And we'll use the stereotypical image. You don't have to draw this. I'm just drawing it to fulfill or to occupy the boredom while you're writing. We have a tree. Nice tree, yeah. A very particular stick man who has the biggest feet ever.
Is it Mr. Newton?
Not just Mr. Newton, it is Sir Isaac Newton.
Sir Mr.
Street
Isaac
named after
Newton.
him in Rome.
Sorry?
He has a street named after him in Rome.
Really?
Yeah.
And also in where we were going for vacation, Gran Canaria.
Okay, he's a bit of a famous dude.
Yeah.
It's amazing how a few little scribbles and you can say, oh yeah, that's Sir Isaac Newton. I mean, it's an unintelligible, horrible drawing, but oh yes, it's Sir Isaac Newton. So what's he meant to have done? Enya?
Did he find gravity?
Did he find gravity? Well, it was a bit late if he did. He understood gravity maybe for the first time. He came up with the first mathematical laws about gravity. So yes, he came up with some theories about it, allegedly through an apple falling on his head. That's an urban myth. Well, it's not an urban myth because there weren't many apple trees in urban England at the time. He was in his parents' orchard in Cambridgeshire because he'd run away from London because London was full of the Great Plague and he didn't want to die. So, and he did all sorts of different contributions in science, like the colours of the rainbow and the invention of the cat flap.
Yeah, from the door.
From the door, yeah. We don't have many of them here.
But what are the colors of the rainbow? Does it include indigo? I say not.
Oh, more debating.
Yeah, why did Newton decide there were 7?
There's 6.
Newton could easily identify 6 colours of the rainbow. But he was insistent that there would be 7. Why? He was religious.
Yeah,
And
because
7 is a more significant number in Christianity, and I also believe in Islam than 6 is. 7 deadly sins, 7 days of the week, 7 pillars of Islam, I think it is. So, not that Newton was worried about that. So he came up with 7. Indigo was just invented, really. So anyway, he was a clever dude. Now, the thing about gravity is if I have to label it, I would always label it as a arrow pointing down.
How about if there's like, isn't gravity also like, isn't gravity also affect in space?
Yeah,
So then if you fly,
yeah. If I drew a globe here, you don't have to draw this, right? And this is us on top of the world, Finland. We are. And then we have
Matter of perspective.
Malaysia and Japan. Gravity always pulls down.
to the center of the Earth.
Does it? That's better. So why does the Earth move around the sun, which happens with football?
Yes.
Because then the Earth always pulls towards the sun, or like moves around the sun.
So gravity's pulling
It's,
that way.
no, it's
So not towards the centre of the Earth.
it's attached, and then it like spins.
It's attached.
Yeah.
Well, there are big strings out there.
Yeah. And then it goes like,
It does go like, yeah, but how could we then define the direction of gravity? Gravity
moves in a circle.
You know.
Gravity pulls
Lighter objects
an object.
towards a heavier one.
Hang on.
Or a one
Towards.
with
No,
bigger
no, but it moves on its
gravitational
it's-
pull.
on its circle thingy, and then it's like that's what defines how it moves, and then it's like it moves like according to the center thingy, and then if it's on a bit like wrong, if you send up like a spaceship thingy or satellite to like up from Earth, and then it goes on the wrong track, then it starts orbiting the. No, if it goes on the right, then it goes orbiting.
You're like the Duracell bunny. We wind you up and you go and go and go and go and go.
Yeah, but when does it stop though?
When does the battery run out?
You know what you're saying.
It's a Duracell.
I haven't got a clue. Right, let's give you the 2 objects. Okay, gravity pulls things towards the center of the heavier object if that object is much, 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 much heavier.
How about
Why I
it's
get all the
burning?
girls.
How about if it's burning? Now, if you are away from the solar system, Selena's just gone off on one. She's out in orbit in space. So you don't have to draw this. So here we have Selena trying to explain gravity. She's about 10 million light years away. But it's a bit lonely out there, so you're allowed to take a friend. Who would you like to take? Okay.
But that's mean.
Why?
Because she just forced Lumi to be in space. Like a million light years away from us.
How about if
It's not real. It's not real. If it was, well. Now, there's no other star, planet around. You're just floating in space.
How could I eat?
I'm sorry, but you're going to die. Hate to break it to you.
So tragic.
I know, sorry. You've had a tough deal from me and I'm now killing you. So, you're out in space. Like the Earth is just in space, but the Earth is trapped by a heavier object.
A
the sun.
bubble.
What?
No, it's trapped
Now-
in a bubble with
just-
the magnetic field.
No, you're dead, okay? You're dead. But you can listen. Now, these two objects that we are calling Selina and Lumi, sorry about it. I'm so sorry about this. Your masses in space, your substance out in space, like the Earth is, we just happen to be on the Earth. And because you are two objects, you've actually got gravity between you.
Friction.
No, we have got friction at the moment. And in fact, what's going to happen is that Lumi is going to have no choice, but he's going to be pulled towards Selina for more explanations of gravity. And in fact, it's going to work the other way. And you're going to be pulled towards each other. So gravity is a force that pulls objects towards each other. The apple falling from the tree also pulls the Earth towards the apple. But the force is not noticeable because the Earth is so much bigger. You don't see the Earth move towards the apple. You see the apple move towards the Earth. Yeah.
So like, if me and Lumi are we gonna get like squished, like first we're gonna be like,
Yes, you are actually going to accelerate towards each other.
and then we're gonna squeeze together, like.
Then there'll be some friction, yeah, and you might compact down. But this is how atoms originally joined together in the universe. There were atoms all over the universe, and gravity pulled individual atoms together. And when they got closer and closer, they accelerated so much that these nuclear reactions began, and we got stars beginning. Valentino, did you?
Yeah.
Yeah?
If I was all alone in my space, I urinated, would I go in the opposite direction?
Yes. Which you could counteract by farting. However, if you were sort of alive long enough to urinate, you wouldn't really be able to use the urine as a jetpack system.
He was hoping for that, though.
How about
This is suddenly where I see the boys have an advantage in space. Now, you two are in space with that happening. Doesn't matter. It's also happening on Earth. And it's happening between every single object. You are gravitationally attracted to each other, to the desk.
No, but how about if I have two feathers and they're like,
Yeah.
they're not gonna go like.
No, why not? Gunnar.
Because I'm heavy out.
Yeah, a heavier object is pulling them, and the gravitational force is so tiny that air is going to slow it down. But if you had them out in space, over time, they pull together. So this is going on. It's just that the force of this is going on all the time. It's just the gravitational force between you sitting next to somebody is a billionth of a billionth of a billionth of the force of gravity pulling down on you from the planet. But it is mind-blowing. Okay, so that is gravity. Yeah, Gunnar.
So if there was enough people on Earth and everybody gathered in the same place and jumped, would that Earth go up? No, I've seen the video of it.
There's all sorts of different explanations of that. No, because it's so the combined mass of the people on Earth is so tiny it wouldn't have an impact.
But if there would be enough.
Yeah. Yeah. And now you're thinking theoretically that, but what if?
Yeah, and if there was
Yeah,
a huge like mountain and then people lifted it and then they like dropped it.
yeah, yeah. Then it would have a huge impact. Yeah. So, for instance, some of the great movements of plates on the Earth, some earthquakes, have had a result on things like the spin of the Earth. There was it the Fukushima earthquake? After that happened, Google Maps was out by about a meter. If you looked at the satellite images on Google Maps and compared them to the maps, they were out by about a meter after the Fukushima earthquake. Yeah.
Where does black rain come from? Like after like atom bomb.
Now look, that's too random even for me to fall down. I'm not going to go down that path. It comes from the nuclear bomb. Some other time. Nice try. Too random. Okay, the other force that we have talked about is friction. Now, what's friction in Finnish? Okay, friction. And this is a force that always tries to stop movement. Which could be a good thing if we want to stop our bikes, our cars, we need a braking force. It could be a bad thing if we're skating on ice, skiing downhill. Okay. Friction allows us to walk, to write, because if we didn't have some sort of grip, we'd fall over all the time on ice, like on ice. If we didn't have a rough surface on our paper, it couldn't grab hold of the lead in our pencils and keep it there. Yeah, graphite, lead in the conversational sense. Friction allows us to walk, to write, to sit, etc. Otherwise, we would slide.
My bag always slides when I'm trying to sit in the bus, and it's like I'm trying to keep it here, then it goes like.
Yeah. You need a high friction bag. I mean, it's always a gamble as to what sort of shoes to wear in this weather. And you lot don't pay any attention to that, so you're all out in your thin sneakers. But I must admit, I haven't got them today. I didn't wear my ice bugs today. But 8 years ago, I bought a set of ice bugs for about €100, and it's the best €100 I think I've spent in Finland. So that's dealing with specific high friction. Okay. We've got 5 minutes
Why
left.
is this pencil sharpened like this?
I don't know. Some foolish student decided to do that, I would imagine.
With what, like scissors?
I don't know.
Or was
I
somebody
don't
carrying a
know.
knife?
Maybe carrying a knife.
That doesn't sound.
Okay, let's do one more. Up thrust. Or also in English it's called buoyancy. And in Finnish it is?
Never heard.
You've never heard of it. You all know about it, Minnie as an expert. Yeah, you. I cannot begin to draw it properly, so I'm sorry. It's going to be,
A boat.
it could be a boat, but I'm trying, I like living
flower.
things. A flower.
A duck. Which is
Beautiful bird.
A beautiful bird.
Oh my god.
It's an albatross.
I like it so much. It's amazing. Can I take a picture of that?
It's fabulous.
I promise I will set it as my black screen background.
Yeah, I want to see, I want to see comics.
I've copyrighted it, okay? You can't.
Please. I'll give you 10 cents.
And you will do the correct MLA citations.
Absolutely, yes. Okay. What is this name of the force then in Finnish?
Nosto.
Almost.
Ylä-nosto.
Nostovoima.
Nostavoima, yeah.
Oh boy.
Lift power.
Lift power, up thrust. Lift, up, power, like thrust. Lift force rather, not power, not teho. Yeah.
What about keskipahomi? Keskipahomi. It's the thing I was trying to explain earlier.
Oh, no, the
I know it's not keskipahomi. Yeah, it's the circular thing with the string and then you spin it and then it
Oh, centripetal force.
Yeah.
Yeah, okay, that's complicated. We've got a few weeks to go before we talk about that.
Oh, I know about that.
There's centripetal.
Part of this?
Yeah.
Yeah.
Okay. Which direction does Nostavoima act in then?
It lifts you up.
Lifts you up. It's a lifting force. Yep. Okay. So that is acting upwards. So this pushes up from fluids. Fluid is a liquid or a gas. You actually get upthrust in air, but you get more Nostavoima from water. And you therefore have to control your muscles slightly differently than you would in air.
I don't think it's the thing that you float in water.
That's upthrust makes you float in water.
But isn't it?
It's also to do with density.
Yeah, I know, but like, I mean that, isn't that like a different thing? Cause then like, okay, I forgot what I was gonna say, but like.
I'm not laughing at you. That's okay. I love the way you do ask loads of questions, even if they seem to be curveballs, to use a baseball term. Curveball is a baseball term, isn't it?
Yeah, that's following the thing and everything.
I think probably you've had enough for now.
Can you keep us here so we don't have to go to finish lesson?
You've got a break time.
It's only 15 minutes.
What's wrong with your Finnish lesson?